I got a really interesting offer recently. You know my true love for this forgotten air-cooled piece of engine engineering art, so the offer sounds like this. I will build one engine for my subscriber from Spain for his nice-looking retro car. He really loves it and he wants to keep it looking perfect. Fortunately, I have one in my donor car, so let's start working. I'm not sure this engine will turn out to be the most reliable one, because it has its own quirks, there are almost no high-quality parts available for it, so it will be a real challenge, but let's see what we get. Unfortunately, it's impossible to save this yellow donor car because it's completely rotted out, but this particular engine is very interesting. Let's start disassembling it. After the cylinder heads came off, we can see that it's not that bad inside at this point. It's expected that this engine was drinking a lot of oil. All the parts are really dirty. Oh, I wish we had an aqua blasting machine. I already can see that this is quite a rare modification with aluminum cylinders, or to be precise, aluminum cylinder housings. These are hard to find because usually this engine has cast iron ones and they have 4 times lower heat dissipation than aluminum versions. The cylinders are bad, which is not a surprise. There are some leftovers of honing and scoring marks as well, but it's interesting that these cylinders and pistons don't have severe seizure marks or galling, because it's so easy to overheat them, especially considering that they are really prone to oil leakage, and all those oil leakages mix with dirt and dust and then transform into quite thick heat insulation. Even for me, it's doubtful that I can rebuild this engine without any potential leaks. But let's see. Clutch needs to be replaced, obviously, but it's not that bad as I expected considering the appearance of this engine. Oh no, the lifter bores are worn out. It's not good. Because we don't have an impact wrench, it's very hard to unscrew this flywheel bolt. We tried different wrenches and tools, but we ended up welding this lever to the bolt and it worked. Then we can easily remove it by breaking it off. Nice and disposable tool. It's not an ordinary bolt. It has a roller bearing inside for the input shaft and it's no longer available, so I came up with an upgrade for it, but more on that later. The oil seal became almost plastic-like. However, the sealing surface on the flywheel is okay. Good news! Let's continue disassembly. Well, not good news. As I said before, the lifter bores are worn out, severely worn out. I can feel a reach inside with my finger. Of course it's possible to rebore them, but I can't even imagine how much it costs. Next, the bad news isn't over yet. I hope you can hear it. It has at least 1 millimeter of play. It's almost impossible to restore the bores in this engine because we don't have any mechanic shops in our city capable of performing such operations, or at least not for a fair price. We need a new block. Would you look at that? I'm 100% sure this engine had enormous oil changing intervals. How could I guess that? I don't know. Well, first I bought a new camshaft. It's brand new. Then I bought all new gears, a new oil pump, new main and rod bearings. Also I bought new bigger pistons and rebored the cylinders. I asked the machine shop to make 0.08 millimeters of clearance. This amount is good for an air-cooled engine, especially considering the owner is going to use this engine for fun driving, not for fuel economy. The dog is always supporting me, as you can see. Are you? Where was I? Oh, I found the correct size of the connecting rod small and pin. It slides really nicely, and finally the carburetors arrived. These are two Delorto 36 carburetors from Alfa Romeo. They were overhauled by an experienced guy, so I don't need to do anything with them. Why are there two of them? Just in case, we are going to use only one of them. I'm sure it will feed this 1.3 liters engine till full. Buying new main bearings for this old engine is a tricky process. Despite the fact that the crankshaft was grinded within the manual specs, the new bearings behave differently. The front bearing from one batch plays on the journal like it was already used for years. You can even see the actual play. It has about 0.5 mm of clearance, if not more. They are both first oversized bearings, 0.25 mm oversized. But when we take the bearing from another batch, it fits here just perfectly. That's weird, but it shows the quality of the parts for old engines. I'm changing the small end bushings on the connecting rods. It's quite an easy and satisfying process. First, I'm removing the old bushings by cutting them, and then the new bushing goes in using this simple tool. It presses there quite tightly, which is good, but not enough for reliable operation, so I need to flare the bushings. For this task, I came up with this simple tool. This wheel bolt has a good conical shape and it's perfect for this purpose. By rotating the rod and tightening the knot, I can flare them nicely, and the last step will be giving them to the machine shop to mill these bushings precisely. So the wrist pin goes here perfectly. Well, as I said before, it's a new block, though it's not exactly new, but in good condition. It's much better than the previous one. And now I'm ready to put everything together after the machine shop finishes rebuilding the cylinder heads. The fuel pump takes a little treatment. After flattering all the maintenance surfaces and installing a repair kit, it starts to shine and is ready to work. Timing gears are ready to be installed. This engine has a balancing shaft, obviously because it's a V4 engine and it has uncompensated alternating forces. I bought two camshaft gears because I don't trust either of them. They are suspiciously different, so I need to check them thoroughly. Let's start with the first one. Well, as I suspected, a problem occurred. This gear isn't within specs. Particularly the gear is binding against the thrust plate, preventing it from rotating freely. I knew it, it was too suspicious. The second gear seems to be okay, because it has a smaller hub shoulder. Yep, it fits correctly. As you can see, this is the construction of the balancing shaft. It goes right through the camshaft and rotates faster than it. These are the piston rings from Malay. They should serve much longer than the original ones, considering that now we have modern pistons installed here. I wish this kit had 3-piece oil control rings, because they work much better in such heat-stressed conditions in an air-cooled engine, but unfortunately we couldn't find such rings for this size. I hope we will be satisfied with these 1-piece rings. They seem to be high quality. Ignition distributor needs to be redesigned for the electric ignition system. We just need to remove almost all the mechanical components from it and install a trigger wheel and a Hall sensor. Electronic system is very reliable, so there is no excuse not to do this. After the modification, we need to check whether all 4 trigger ends are symmetrical and give a consistent signal. I use a printed paper disc marked with 4 equal sectors. New rod bearings. They smell like a true treasure from the 1970s. The starter needs to be cleaned and maintained. These are the pistons. They are 79 mm of diameter compared to 76 mm original ones. It allows us to achieve a higher compression ratio and gives us a nice bump in displacement of about 100 cubic centimeters. It was 1.2 liters and now it's 1.3 liters. It connects with the connection rod without any issues, so it's a good modernization for this ancient guy. Piston installation is quite tricky without a special tool for this task, but it's not a problem if you are careful and precise. Otherwise, the oil control ring breaks instantly, because it's very brittle. Wait a minute, I do have a special tool, and it works just perfectly, and lubrication is a key. Now I'm going to make a pointless thing. I'm going to cut a pancake from this piston because I need small plates to weld up a chamber for the water cooling mod I was talking about in the previous video. Why am I going to do this pointless action? Because we don't have such aluminum material for this kind of task, but we have a lot of old pistons. This is one of 2-cylinder heads. It is cooled completely by air, but it has small channels here and here. It's possible to weld these channels up and we will get nice chambers through which we can run coolant. You may say these chambers are small compared to the entire cylinder head. Yes, I agree. However, these are the most thermally loaded parts of the engine because they're exhaust channels. We have almost finished with these chambers. I just need to press this pushrod cover out because it is in the way of welding those plates in their places. As you can see, it's already welded up, but it has a tiny hole here that we need to fix. The heads are done, so I can show you how this system should work. I drilled holes in these chambers and then I can install these brass fittings, which will allow us to connect water hoses. This way we can cool down these hot areas above the exhaust ports. Since this is an air-cooled engine in the rear of the car, it needs all the cooling it can get. And this is a handmade intake manifold. We decided to make it extraordinary. All the margins were measured, there should be enough space between its top and the hood. It was power coated in black, so this engine is getting closer to being shipped to Spain. Speaking of which, we need to make an exhaust manifold as well. We decided to place the carburetor in this direction to prevent the throttle lever arm interfere with the distributor. So the cable should go here, and we should replace the lever vertically or come up with some idea how to achieve the correct angle for the throttle arm. Well, some final touches here. Good spark plugs, NGK B7HS, I think they are the best spark plugs for this engine, but it's important to buy genuine ones, not counterfeit. Another important thing, this crankshaft bolt was machined and upgraded. We added material on top and machined the bore for the new bigger bearing. The bearing is 6002. Then this bearing goes here and this part becomes virtually indestructible. The flywheel is in its place. Okay, this unit is ready to be assembled. The bolt is tightened and here is how it looks. The input shaft fits nicely here and it's easier now to mate the gearbox to the engine. The original small plastic bearing was too fragile and could easily get damaged during gearbox installation. The modern clutch disc was grinded a little here at the hub so it doesn't interfere with the bigger bolt in the center. Well, we can finish the assembly now. And the first start. Now I'm going to test different carburetors. The first one is Dilutor. It works okay, the idle speed is quite low and steady. It's crucial to install all the cylinder covers, as any air leak reduces the engine's cooling efficiency and can lead to uneven heating of the cylinders and cylinder head, which isn't good. It gains more and more black painted parts and starts to look nice. Well, at the moment I'm satisfied with the result. It works really stable. I'm giving it a short braking period to make sure everything works correctly. By the way, this is the third carburetor I'm currently testing, and I would say even without installing the engine to the car. They all have their quirks and advantages. Let its next owner choose which one is the best. But then, after I shipped the engine, the worst case scenario happened. The engine seized up. I immediately asked the engine to be returned. I started to disassemble it and I found two issues. The rear main bearing was seized for an unknown reason, though the rear crankshaft journal was untouched. And the biggest surprise was the piston wrist pin scored the fourth cylinder severely. Everything had been checked twice during the assembly. How could this happen? I don't know. This is an unknown wizardry for me. But I had no choice and I fixed these issues. I had to find this rare aluminum cylinder, machine it in size, swap the rear main bearing, and the engine was finally done. After that, the owner did some additional tweaks and there were some small issues which he fixed. Overall, the final assessment of my work was okay. And that's fine, but I learned one important thing. It's pointless to overhaul and modify such old engines because they are too unpredictable. This should remain a hobby just for me and my father, or at least we need a proper workshop with lots of good tools and machines. Maybe that will happen someday. Well, see you under the hood.